There we go. Okay, so you have just been looking at dividing polynomials. Today we're going to continue doing so, and we're going to be using new words like factors and zeros. Now those aren't new to you, so we're just going to apply them in a new way. So I want to kind of go, and I'm going to just write up here a prerequisite question, because I want to make sure that you just know what these terms refer to. So just call this prereq question. If I ask you, is 3 a factor of 282? What would you say? Is 3 a factor of 282? Some of you are shaking your heads yes. Yes. Why is it a factor? Okay, Jason's saying plus 2 plus 8 plus 2. He's adding the numbers, and he says if this number is divisible by 3 when you add the digits, 2 plus 8 plus 2, that means that the number is divisible by 3. Yes. Another way we can look at it is if I take 282 and I divide it by 3, I get 94. And so that tells me that 3 goes into 282 evenly, meaning that the remainder is equal to 0. That's another way to know if something's a factor. The remainder will equal 0. Now that's a basic question. You've done something like that back probably in elementary school. Now we're just going to apply it to the new types of problems you're doing today. So looking at the next question, it says divide f of x, or take f of x, which is x cubed plus 1, and divide it by x minus 1. Okay, you guys have learned long division and synthetic. Which do you want to do to divide this?
Long.
Long division, really? Man, all right. If you like long division, you can do it off to the side. I prefer synthetic, so I'm going to do synthetic division since this number is in the form that you can use synthetic. Okay, so you can do your long division. I'm going to do synthetic off to the side.
I can't see it.
Oh, no, sad day. Okay, so I took minus 1, and I made it positive. What do I line up next to this box if I was doing synthetic?
X, 0, 0, no, 1, 0, 0, and 1.
Awesome. He's taking the coefficients. Why did he say 0 and 0?
X squared.
Yeah, we're missing x squared and x, so I got to put those in there. 1, 0, 0, 1. Do my bar. Bring down the first term. Multiply. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 1 plus 1 is 2. So if I looked at this in, God bless you, in answer format, it would be 1x squared plus 1x plus 1 with a remainder of 2. Right there, remainder of 2. So that's going to help me answer the next question. After dividing, is x minus 1 a factor of that function? No.
R2.
Exactly. We know because the remainder does not equal 0. Okay, now I want you to see something that's actually also kind of cool. Look at the next question. It says evaluate the function at 1. Notice I put 1 here for synthetic division. Now I want you to just try to evaluate the function at 1. So go ahead and do that with your partner. Probably be pretty quick. All right, I heard an answer of 2. And you, I heard you notice something. What did you notice? It's equal to the remainder. Notice the function, when I plugged in that box, that number 1, it equaled 2, which is the same as the remainder. These are the same. So what do you notice? We notice that they're the same. And this is actually the next theorem that we look at. It's called the Remainder Theorem. The Remainder Theorem says that when dividing x minus c into a function, it's going to be equal to the same value as the function evaluated at c. So let's see how that helps us as we look at different types of problems. Notice, if x minus 1 is a factor of a function, so if I kind of think about that in this way, if I think that x minus 1 times something else is equal to the function, I can think of it in that way because I know x minus 1 times something, there's going to be no remainder. So that product will produce the function. Now if I think about it in that way, what do I know about the graph of f of x? What do I know about the graph of this function if you know x minus 1 is a factor? Nice. Nice, Daphne. Daphne says we know that one of the zeros is equal to 1. Because if I have x as 1, that will make the function equal to 0. So yes, I know that one of the zeros is equal to the number 1. All right. Okay, after thinking through that, let's answer questions A through B to verify again that this is true for the polynomial and the divisor x minus 3. So letter A, find the remainder when doing division by x minus 3 and also evaluate f at 3. And just confirm that they're the same. So go ahead and do this with your partner. I'll give you a few minutes and then we'll stop after you finish letter B.
You just divide by, yeah, so you can use Oh, I see.
No, we did the one. Wait,
Oh, wait.
you get a remainder of 5.
So, negative 7. Because you bring down the first.
Oh,
Like up
that's
against
why.
up there.
Yeah, that's what
You bring down the first number.
Yeah, yeah. If the last number is always the number. Yeah. Okay. Yeah, we got this. Oh, yeah. Is that to do 0x.
Oh, for that, yeah, I did 2x. Or wait, I meant to put 2. So yeah, 2 times.
I mean, you're supposed to confirm it. So. All right, guys, I'm seeing most people nearing the end. And do you find the same thing happening? Does the remainder come out to equal what you evaluated the function to be at that point? Yes. Okay, now this is just a personal question for you. Which step do you like better? A, where you use synthetic division, or B, where you evaluated the function?
A.
Okay, hearing different responses.
For A and synthetic division.
Oh, you're supposed to evaluate for B. So be careful when you see that. You want to make sure that you know what that implies. Okay, now that's up to you, but I'm just going to tell you there will be certain times when synthetic division may be easier and times when evaluating might be easier. We'll see on the next page how you might prefer a different method. So flip it over to the next page. Example number 1. Determine whether x minus 1 is a factor of that polynomial. Okay, this is a power of 98. So we're missing the terms x 97 through x to the 73rd power. Do you think it would be beneficial to use synthetic and put a bunch of zeros there? No. What would probably be easier in this case? Evaluate. What would we evaluate if x minus 1 is a factor? Yes, we would evaluate f at 1. So I would go ahead and plug that in, and I have 1 to the 98th minus 1 to the 72nd power plus 1 to the 45th power minus 3. What's 1 raised to any power? 1. So I have 1 minus 1 plus 1 minus 3. Gives me 0 plus 1, which is 1. 1 minus 3 is equal to negative 2. So this function at 1 is equal to negative 2. So let's think about answering this question. Determine whether x minus 1 is a factor. Is it a factor? No. The remainder is negative 2. The remainder would have to be 0 for it to be a factor. So no, the remainder is equal to negative 2. Daphne.
If it said determine whether x plus 1 is a factor, would you put in f negative 1?
Exactly. Yeah. Because when you're doing synthetic division, you take the opposite. And realistically, if 1 was a 0, then I would have, 1 minus 1 equal to 0. So I have to take that opposite number. Good. All right, example 2. Completely factor f of x equaling x cubed plus 4x squared minus 5, given that 1 is a 0. Okay, if 1 is a 0, then what do you know has to be a factor of this polynomial? Okay, so therefore we know x minus 1 is a factor. So how can I use that to completely factor this polynomial? Do division. We're taking x cubed plus 4x squared minus 5 and dividing it by one of its factors in order to completely factor it down. So I can go ahead and do synthetic division, or long division if you prefer. I'm going to take 1, divide it into this function. So I have 1, 4. Do I have any missing terms there? Yeah, which one's missing? X. So I got to put in a 0 here. Be careful. I tend to miss those things when I make those mistakes at the end. All right, so I bring down the 1. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. 0 plus 5 is 5. 1 times 5 is 5. Negative 5 plus 5 is 0. So I put this back in answer format. I took x cubed and I divided it by an x, so I know I'm going to start with an x squared. So 1x squared, or also known as x squared, plus 5x plus 5. So that means since I took this and divided it by one of its factors, that x minus 1 times that result, x squared plus 5x plus 5, is what equals this big polynomial. The only thing that I really also need to check is it told me to completely factor. So I want to make sure that this here is completely factored. How would I check to see if this can be factored any further? You could try doing the trial and error, right? See if I have x and x, it has to be a plus sign and a plus sign. If I do 5 and 1, is there any way that this could factor and add up to be a 5x? No. So did we completely factor this? Yeah. So this would be my answer. Any questions about this so far? Give me a thumbs up, side or down, how we're feeling. Okay. All right, let's go to example 3 then. Example 3 says completely factor this polynomial given that both x minus 4 and x plus 2 are factors. Okay, so where's a place we could start here? Where's a place that we could start? If we know this and this are factors, how could we use this to factor this? Divide out one of them. So let's start with 1. Doesn't matter which one you start with because we know they both divide into this. So if I'm going to start, and I know I'm writing a lot here just because I want you to be able to see what I'm doing, but I'm going to start taking this and dividing it by just one of these, x minus 4. So I'm just going to write that. You don't have to write this, but I'm just showing you this is what I'm doing. Oh, whoops, x to the 4th minus 14x cubed minus 14, or minus 71, sorry. X squared minus 10x plus 24. And I'm dividing it by one of its factors, x minus 4. I'm going to use synthetic division. I just like it. So I'm putting 4 in the box. Let me zoom in. And I have 8, negative 14, negative 71. That is so poorly written. And negative 10 and 24. And bring down the 8. 4 times 8 is 32. Negative 14 plus 32 is 18. Yep. 4 times 18, 40 plus 32 is 72. Negative 71 plus 72 would give me 1. 4 times 1 is 4. Negative 10 plus 4 would give me negative 6. 4 times negative 6 is negative 24. 24 plus negative 24 is 0. So this means that this polynomial divided by x minus 4 will produce this result. 8, and if I put this back in answer format, it would be 8x cubed plus 18x squared plus x minus 6.
Wait, so you just dropped the highest one?
You drop the highest one because you're taking an x to the 4th and you're dividing it by x. And just like long division, you know that x to the 4th divided by x would start with an x cubed. Okay. All right, so we know that this divided by x minus 4 is going to give me this. Or in other words, I could see this as x minus 4 right now times this huge thing, 8x cubed plus 18x squared plus x minus 6 is what this has factored down into right now. Did I factor it completely? No, so what can I do now?
Continue to factor.
Continue to factor. What else do I know goes into this? X plus 2. So I'm going to take negative 2.
Wait, or x minus 2, right?
Not x minus 2. It told us that x minus 4 and x plus 2 are factors.
Got it.
So now I put in negative 2, right? And I'm going to line up this. So I have 8, 18, 1, negative 6. And I bring down that 8. Negative 2 times 8 is negative 16. 18 plus negative 16 is 2. Negative 2 times 2 is negative 4. 1 plus negative 4 is negative 3. Negative 2 times negative 3 is 6. Negative 6 plus 6 is 0. And here's this last factor, which is 8. Now what am I going to start with? I took
squared.
Good. 8x squared
Plus 2x.
plus 2x minus 3. So here is what I've factored so far. I've divided this big polynomial by x minus 4 to start with, and then I divided it by x plus 2 because I knew that those were factors, x minus 4 and x plus 2. Sweet, I'm almost done, but I want to make sure it's completely factored. Look at the directions. It says completely factor. Can this trinomial, 3 terms, can it be factored further?
Yeah.
Yeah, it actually can. So I want to make sure that I factor that piece down. The last term's negative. So am I going to have same signs or different?
Same.
Same. One's going to be plus, one's going to be minus.
Wait.
Oh yeah, I said same, but I did it right. You said same. Yeah, it's minus, so it's going to be different signs. 1 plus, 1 minus. What times what would give me 8x squared? 4x and 2x. And then only 3 times 1 would give me 3. But where would I put the 3 in order to add up to the 2x? In the one with the 4. Good. And then you can check, does negative 4x plus 6x equal 2x? Yes. And ta-da, we factored it completely. This is amazing. What are the new people, what are the kids saying these days? It's lit. Yes. What? No. Okay. Maybe I shouldn't put this video on there. If we take a look at example 3, I was just kidding. I hear you guys say that, and I'm like, what? That's interesting. Okay. Now, I wrote a lot down because I wanted you to make sure you understood what we were doing in the process. You could have just started with dividing by 4, and then you didn't even have to put it back in answer format here. Right underneath, you could have just said, okay, I'm going to divide this by negative 2 because I know it's another factor, and then ended at the bottom. But I wanted to make sure you could see as you go back and look at this in future days why we did what we did. Okay. All right, example 4. Example 4 says take that function we're going to see why is graphing so helpful, especially in a case like this. Graph this function from example 3 above using your calculator and find the zeros. Before we even do that, what should the zeros be?
4,
2, -3/4, and 1/2.
and 1/2.
Right? Let's just confirm that. Let's see how we could have found those zeros just from that function. So I have 8x to the 4th minus 14x cubed minus 71x squared minus 10x plus 24. And graph it. I know I have something on my screen. Okay, these zeros do show up at +4, -2, -3/4, but how can I confirm? Again, what do I press on my calculator? Second trace, go to 0, right? We got to do the whole left bound, right bound of each. Whoops. If you're ever wondering where is my cursor, it tells you at the bottom of the screen. So this is at -1.9, -4.3 is where I'm at. That's the left of that 0. And then I would go to the right of it, press enter, enter again, and that would tell me that first 0. Oh, after I make a guess. No sign change. Did I go too fast? 0. Where is this? There we go. Enter. Go to the right. Enter. There we go. Enter again. What? Why is that not working? Second trace, 0. Why did it say no sign change? Oh, I didn't go to the left. Here's where my 0 is. If your calculator says no sign change, it means you did not go from left to right. So instead, do it again. And I didn't follow my cursor right. This left 0 is at -2. So I want to make sure I'm to the point to the left of -2, like -4. Press enter. Then I want to go to the right of -2. And here's the other cool thing. You could type it in. I can type in -1, which is definitely to the left of -2. And now I've got a boundary here that will help me find that 0. So press enter, and there's that 0 at -2. All right, but you could do that for all 4 of those, and you will find the zeros to be -2, -3/4, 4, and 1/2. Any questions on that? No. Technically, we usually go from smallest to highest, but I didn't even do that because I didn't put 1/2 in 4. Okay. All right, let's try. Now that's nice. If you have graphs, you can sometimes find all of the zeros. But look at example 5. It says graph the function and find the zeros. Let's try it with example 5. If I graph x cubed plus 2x squared plus 3x plus 6. It only found me 1 0. If I found that second trace 0, it looks like it's at -2, so I'm going to go to the left of -2, like -3, enter. The right of -2, like -1, and then press enter, and just to confirm it's not a decimal answer, yes, it's -2. So, find the zeros, there's only one real 0. We're going to find soon that there are actually also 2 imaginary zeros in here. But for today's purposes, we want to see how can we factor this, which will help us find imaginary zeros. So now that you know this is a 0, completely factor this using the 0 that we found. And factor using synthetic division. All right, with your partner, why don't you try number 5B?
Well, if we saw the zeros here, and they were like the opposite, what you just still look like that. Because it's an X mix.
Can we get 0? X squared plus 3. Yeah. Because it's like the opposite.
All right, how did we do? Did we get x plus 2 times x squared plus 3? Yes. Thumbs up if you got it. Okay, let's see if 5c, we did that one using a graphing calculator to find the real 0. Could you have factored this polynomial in a different way? Yes, good man, Justin. We could factor by grouping. So, because that's really helpful here, let's just go ahead and review that. What can you take out of the first two? X squared. We have x plus 2. Copy over the x plus 2. What times x would give me a 3x? 3 here, and then check it. 3 times 2 gives me 6. Are you guys okay? All right, so we have x squared plus 3 times x plus 2 when we group it, which is the same thing we got up here. All right, I need to stop recording.